All right, welcome back. In this video, we're going to take a look at many of the common issues that people run into while dealing with HTML templates. Now, you don't want to put extremely complicated code in your templates, but on the other hand, it can be extremely convenient using functions and methods to, say, format your text inside those templates. Say, for instance, if we have a value that we're bringing in that's on a struct and it is a float 64, we can format that to only show the last two decimal places, make it look a little bit nicer. Or we could capitalize something. Say, for instance, we had a struct with a Boolean value. We could have it display active or inactive depending if it's true or false. So anyway, let's go back to our code. Now there's going to be a couple different places where we're going to see different issues people are going to run into. So it could be while we're parsing our files. Say, for instance, while it's parsing this, if it doesn't know what to do with it, that could be an issue. We can also have issues where something's not showing up depending on, say, if we're passing in a struct and one of the fields is lowercase, well, that's not going to show up. And then even if, let's say we get a couple more quite a few functions in one of our templates. One thing to be wary about, because sometimes it can be during the execution. While we're executing that template, we could run into an issue. So up here, for instance, when we're using the execute template method, one thing to be aware of here, of course, we're executing that template. We're taking our data and we're taking that parse template and we're executing on it, but we're also going to be writing to that response writer in all in one step. So one of the issues here, this does return an error, but the problem with that is if I'm returning that error, I've already written to that response writer. The user could get half a page rendered because I say one of the functions returned an error. But to get around that, we can break apart that process. We can do we can execute our template, save it to a chunk of memory. We could check to see if there was an issue and then handle that issue if there was. But if everything runs fine, then yes, then we can go ahead and write it to the response writer. So anyway, let's go ahead and take a look at our code. So we have TPL, which is short for template. And this is just a pointer to a template. So inside the template package, we have our data type template. And if we take a look at that, and we have this data type template. It says template, but really you could say if you parse many files, there could be many templates in there. So just think of it as a tool for working with our templates. But anyway, it is just a struct, but it has many different methods that can be useful for us. So we've defined TPL, short for template. And we run template.new, and this is going to give the template a name. Now, I understand that, yes, when we run parse files, it's going to go ahead and give all of our templates a name of whatever that file name is. So a little bit redundant. So yes, we're going to have it's just going it's index.html. But say, for instance, if we're just making one, it has to have a name so we know how to refer to that template. Anyway, and then we're going to use TPL. We're going to use the method funcs, which is going to take a func map. So our func map is just a map of the functions that we want to pass in, that we want to be able to use. So we've created our func map up here, and it's of type template.funcmap, so it's compatible. And we have our function here that this function here that we've created. So anywhere in our template it sees this name, it's going to go ahead and run this function, just like we have over here. Now, on the other hand here, we have another function here, upper. Now, this one is actually one we're borrowing from the Golang core packages. In the Golang core package strings, we're going to be using the toUpper function, and so you can do that as well. So taking a look at our can cache price, so Canadian cash price, what you'll notice is that this is going to return in increments of 5 cents. In Canadian money, they don't have a one piece, so it's in increments of 5. So that's what we're doing there. Let's go back here. And so we can return, say, a string, but we can also return, say, if we run into an error, we can return an error. And inside our template, if this was to return an error, well, then it's, it's not going to go ahead and, return a value for us here. It's just it's going to stop parsing on the way, the rest of the file down. We'd have an incomplete page in our browser. So anyway, so we attach our func map that we've created using the .funcs method, and then we're going to go ahead and parse our files. So we have a couple different ways of doing this. Notice that this returns an error, and we're not actually doing anything with the error, which is bad form to begin with. But just to show you what happens if you don't handle that, let's go ahead and go over here, and let's go ahead and put in an error. I do not have a function called car in our func map, so it's not defined. So we're going to run into an issue here. So let's just go ahead and do that. And notice that we don't run into an issue right away. What we do want when we will handle that error, we want to see that issue first thing. So let's go here, and our page doesn't display because it can't parse the template. And notice this gets a lot more complicated here. So if we go back to our go run main, our handler was running, but notice we get a panic. Now, usually a panic shuts down your program, but a web server is a little bit different than most programs. So usually you would shut it down. Most Golang applications would just shut down immediately. But with a web server, you may have many different people, looking to get their pages, looking for, trying to use your website. So it's commonplace to try and keep the web server up and running if you can. So inside the HTTP listen and serve, it's going to try and handle, it's going to let us know about these panics, but it's going to try and keep the web server up and running, because if some little thing goes wrong, you don't want to lock out all of your users from being able to use a website until someone can get to it and fix the issue. So as you can see, we actually have a couple of these different panics. You can see this is go routine 6 and go routine 34, and so on and so on. So the stack trace isn't exactly that easy to understand, so it's just much easier to handle a parsing error when we get to it. So let's go ahead and handle this a little bit better. And we're going to use in the template package the must function, and taking a look at that. And the must it's a helper that wraps to call a function returning, and it's used to variable use such. So basically, this is going to make sure it has to be error free, or else it's going to panic and stop the server first thing. So let's go ahead and run it now. Okay, this is going to be a little bit easier to understand. So we have our go run main, and see our panic is up here. It says panic template index HTML 16 function car undefined. So if we go down to line 16, yes, here's a function we've put in. It's not defined. There's our issue. So much easier to understand than looking at the previous stack trace. So anyway, and this is a convenience function. This is the same as, say, for instance, we use this. So we're still parsing our files, and we're returning that error, and then we're just checking to see if that error is nil. If it's not, we're going to go ahead and panic and pass in that error. So let's go ahead and do that as well. As you can see, yes, function car is not defined. Still very easy to understand. Now let's go ahead and take a look again. Let's go ahead and, oops, hold on, I don't think oh, we need to take that out of there. And let's go back. There we go. Notice that we're not getting a value here towards the end, so let's take a look at that. Okay, so if we go up here, we have to look at what the template's going to, what variables it's going to use and what it's not going to use. So, you know, whether the name of the data type or the variable name are not capitalized, that doesn't matter, whether the template's going to use it or not. But whether the fields are capitalized or not on that first letter, that is going to change it. So we have our struct P for price of type price, and we have our uppercase field and our lowercase field. We're passing that in, and so when we pass in P, we have our uppercase field, our other uppercase field, which is getting passed into our function here. And then we have our lowercase field, and then we have the word end. And if we take a look at this again, uppercase field is shown, uppercase field is shown. Now notice, here's one of our problems here. Not only do we not see our value that was in the lowercase field, but the word end has been hacked off as well. So if you run into an issue where you're getting some of your data and not some of your other stuff, and all of a sudden your page is cut in half, just kind of look and see back in your template where that issue might be occurring. So taking a look at it, looks like all this stuff displayed, all of this stuff displayed, but then here down we didn't see anything else appear. So that's going to be our helpful little trick to try and find what that issue is. So it could be an error being returned on a function, or it could be it just can't find a field we're asking it to find. So let's go ahead and move on to our last one. Here's, like I was saying, if this is going, the execute template is going to execute and write to the response writer all in one. So even if we try to handle this error on the other side, we try and catch it and then put in some error checking below it, it's already going to write to that response writer, and we're going to get a situation like that. So let's go ahead and go up to our function here, and we were returning an error that was nil. And as you can see here, no problem. It's not nil, so we're still getting our data. But we're going to go ahead and change this so that way we are returning an error that is not nil. So when it gets to this template, we're going to run into an issue. Now notice we haven't had any issues yet. Okay, there we go. So since it returned an error, it's not going to display our data, and then everything below it's not going to display. And so this is not a good experience for our users, because they're going to see half a page, going to be wondering what's going on. We'd want to just display some other page saying, hey, we ran into an issue. So let's go back to our code. And that's handling it with index handler 1 using the execute template. So let's go back, and we're going to use index handler 2. Okay, so we handled this by displaying a page we wanted to. There was an error parsing page. Yes, I know you wouldn't tell the user that. You just say, hey, we ran into an issue. But anyway, let's go back to our code and see how that was handled, how we got it to display that message instead of displaying half our template. So in index handler 2, we're breaking up the execution of the template and the writing to the response writer for that template. So to do this, we are going to use in the bytes package, the buffer data type. And a lot of people say this is very similar to a slice of bytes. It's actually different. So let's go ahead and go there. So we're in the bytes package, and we have this type buffer. And if we take a look at it, it is a struct, and contains filter unexported fields. So if you take a look at that, these are lowercase because they want to abstract us away from this. They don't want us accessing those fields directly. We should just be using all of these methods, and it'll be a safer way of doing it than trying to access those directly. So it's just a level of abstraction, make it a little easier. It's kind of like my truck has a timing belt that is abstracted away from me. I'll let the mechanic handle it every 100,000 miles. If it's something I could easily tinker with and mess with, I could literally destroy my engine. So sometimes abstraction is a good thing. Let's go back to our code. Okay, so we're going to use this bytes buffer, and I was going to say just a little bit of looking at what a byte is. A byte is 8 different bits. So with dealing a lot of this stuff, one thing that's nice about the bytes package, especially with the buffer data type, is when you're dealing with bytes, sometimes if you're dealing with runes like a character on a screen, sometimes it will just be 1 byte, but sometimes it could be several. For instance, I see here I'm over in this one's the let's see. Oh, this one finds the length. So we have, for instance, in our slice of byte, we have high exclamation point. So there's 3 characters, and yeah, that has a length of 3. But if we look at something else here, say 1, 2, 3, 4, 5, 6, actually has 16. So some of these things have to use multiple bytes because there's just so many different characters. So yeah, you could get the English alphabet, in 1 byte, but you wouldn't be able to get obviously all the different languages in the world. And if you're curious about it, there's a good read on that. UTF-8, Golang uses UTF-8, so it can display characters as, or runes as small as 1 byte. Well, there might be some programming languages UTF-16, so the smallest number would be 16 bits, or 2 bytes. If you're curious about that, if the first digit is a 0, that's basically telling it, hey, this is one. It's going to use 1 byte for this rune, or if it's a 1-1, it's going to use 2 bytes to represent that character. Or if it's 3 1s at the 3 1s and a 0 at the front, then hey, it's going to be 3 bytes, and so on and so on. So you get the idea. Anyway, so it abstracts a lot of this complexity from us, so we don't have to keep track of some of this stuff. Let's go back to our code. Okay, so creating a variable buff, and it's just a byte buffer, which is our handy struct with many different tools for dealing with bytes, especially with UTF-8 stuff. And what we're going to do is we're going to use the tpl.execute, and we're going to go ahead and pass in the memory address for our byte buffer data type, our variable buff, and then we're going to pass in our data, which is P, just like we did up there, and that's just our struct with our uppercase and lowercase fields. And then we're going to check to see if we run into an issue with that. So we still, and then if we, let's say if we have an issue executing that template, well, we're going to check for that, see if the error is not nil. If it is, if there is an error, We're going to go ahead and print that error. We're going to go ahead and redirect the user, and then we're going to return because we don't want this to write, if we're redirecting the user. So, and then it's just another handler. So error for our error handler, and this one's just going to use fprint to print there was an error parsing page. So anyway, and as you can see here, we went ahead and ran that all already. So even if we go back there, index 2, it's going to bring us back to here, as opposed to having that when we run into that error in our template, which is this one right here, because we explicitly gave it an error. There we go, right there. So I think if there's anything else we needed to cover on that, but those are going to be many of the common errors that you're going to run into, whether it's, while you're parsing your files, we want to use something. We actually want to use just out of convenience, that looks a little bit nicer using the template.Must, because it's going to make sure it's going to go ahead and panic and shut down our application if everything doesn't parse correctly right off the bat. The other thing would be, doesn't matter if your data type's capitalized, your variable name is capitalized, on your structs, just make sure that your fields that you want exposed are uppercase, and don't uppercase everything. Say for instance, you have a password hash or something, you want to make sure that's lowercase, so if another programmer came behind you, they wouldn't accidentally expose that through a template by any chance. Just for good process. And of course, if you want to be real secure, you can execute that template to a byte buffer, and you can handle any error that you run into. And if there is no error, then you can just write that. Now, byte buffer actually has a method write. So this execute takes an IO writer. So if we went over to if we go over to that, go to the typewriter. So anything that just has this method write means that it can, then it is a type, the interface type writer. So back to our code. So we could actually put several different things in there. As long as it has that method, we can put that in there. It's just this byte buffer, this little chunk of memory. It's just real convenient, real easy. So we can execute it. So you can separate the execution from the writing to the response writer, should there be an issue there. Well, if you like the video, please like and subscribe. Really does help me out, and it is greatly appreciated. Thank you, and see you in the next one.